In this section, we're going to talk about the difference between observational studies and experiments, and also look at misuses of statistics. An observational study is a form of data collection in which the researcher merely observes what is happening or what has happened and tries to draw conclusions based on those observations. We have 3 different examples of types of observational studies. A cross-sectional study is where data are observed, measured, and collected at one specific point in time. So we would look at one point in time, sending out a survey or observing something happening at that moment, and then using that data. In contrast, retrospective and prospective studies are longer. Retrospective is also called a case control study. Data are collected from the past by going back in time. So you can either, if we're talking about people, maybe go back in time on medical records, or ask them their experiences or their situations from their past, and then determine how that may have affected where they are now. And the prospective or longitudinal or cohort study is where you start collecting data, and you can collect data for a very, very long time into the future. So you start collecting data and you know that your observation is not going to end until months or years later. So this idea that data are collected in the future, we don't have time machines, but we decide to start a study, and then we're going to track cohorts of people from this point into their future. So retrospective, retro going back in time, prospective going forward. Cross-sectional is one point in time. Some examples. Observational studies that are very common right now. Gallup polls. Gallup is a big agency that does a lot of surveys, especially around elections and political issues. And so a Gallup poll of simply the question, who do you plan to vote for? That is an example of a one variable cross-sectional study, one point in time. Another example, a campus survey. How many tattoos do you have? Just a question. And you're collecting that data at one point in time. An observational study with 2 variables could be something like a researcher investigating whether people who are more hostile have higher levels of cholesterol than those who are less hostile. So we're looking at hostility and cholesterol levels and seeing if there might be a correlation there with the observation. The big idea with observational studies, the big picture, the most important fact, is that the subject is not manipulated or modified. So in the study, we're merely collecting information. We're not applying a treatment of some kind and then watching what happens after that. We're just observing. The goal is to describe some relationship. And there are a ton of fields using observational studies. Political science, sociology, anthropology often use observational studies. An experimental study is a different type of data collection. Here, the researcher is going to manipulate one of the variables. They're going to change something and try to determine how that change influences other variables. So an experimental study is a form of data collection in which the researcher manipulates one of the variables and tries to determine how the manipulation influences other variables. In this definition, we actually get the next 2 definitions. The variable being manipulated by the researcher is what we call the independent variable. And this is sometimes called the explanatory or control variable. And then the other variables that are being influenced by that manipulation are our dependent variables. We call this the resultant or outcome variable. And then one of the last definitions for experimental study that we'll focus on is a confounding variable. A confounding variable, just like confounding means confusing, a confounding variable influences the outcome, but it was not separated from the manipulated variable, from the independent variable in the experiment. So it's confusing the results of the study, causing the experimenter to not really know if the manipulation was causing the outcome or possibly a confounding variable. Now, there are some controlling effects of variables, some things that we can do in our experiment to help reduce confounding variables, some things that we can design our experiment around so that confounding variable influences are reduced. Examples include blinding, which you may have heard about a blind experiment or a double-blind experiment. Blinding means the subject does not know he or she is receiving a treatment or a placebo. So when we talk about, for example, the vaccinations, the vaccine studies that are going on, some of the people who volunteered to be a part of that study are receiving the actual vaccine, and others are receiving what's called a placebo. A placebo is just like, if we were talking about medicine, a sugar pill, a fake vaccine. Something that's not real, that's not going to change really the chemistry in their body. This is intended so that we can compare what happens to the group that does receive the treatment versus what happens to the group that receives the placebo. We want to see if the treatment really does help improve whatever situation we're looking at. And so we tend to have this blinding where you don't know as the recipient whether you're actually getting it or not. If you know that you're getting the medicine or the treatment, there are psychological influences that can cause you to think you're getting better or to think you're changing that will confound the experiment. There's a couple of studies that I want you to look at that I'm going to post information on after this video. There's one called the Hawthorne study and another one, the scurvy experiment. So I have a separate lesson for those, and I'll make sure those get up there because they're two really good examples of early experiments, a really good one and a really bad one. Blocking is where we take similar subjects and group them together. So we might want to group people together that have similar physical characteristics. We have something called a completely randomized experimental design, and this means we are basically just mixing everybody up and putting them into blocks. A rigorously controlled design, the subjects are very carefully chosen. Maybe we're looking at something that's specific to heart disease, so we want a certain group to study to see the effects for heart disease. Or maybe, again, going back to the vaccine, maybe we want to study now the older children group, so we want to limit our study for that group. Replication comes in when we have possibly a bigger study and we're studying with enough people so that we can replicate different treatments, or we can repeat the process on the experiment throughout multiple groups of people. And then the sample size is a big controlling effect of variables. We need a sample size large enough to see the true nature of any effects, and we obtain that sample based on randomization. Okay, let's take an example. A study on adverse effects of smokeless tobacco used 40 university students as subjects. 20 were given smokeless tobacco to chew, and 20 were given a placebo. The students were randomly assigned to one of the groups. The students' blood pressure and heart rate were measured before chewing and 20 minutes after. A significant increase in heart rate occurred in the group that chewed the smokeless tobacco. Pause your video, try these questions on your own, and then we'll come back and go through them. So what type of study was it? This was experimental. A treatment was applied on each of the groups. What are the independent and the dependent variables? The independent is what was changed, what was given to watch the influence of. whether or not the participant chewed the tobacco. The dependent variable, what did they measure? They measured the blood pressure and the heart rate for each of these people, which was the treatment group, the ones that were chewing the tobacco. The other group with the placebo is what we call our control group. Could the students' blood pressures be affected by knowing that they are a part of a study? Well, there's always a possibility that it could be, but if it's the case, all the participants would be similarly affected. So we might say likely not, and that they would all be elevated if that was the case. List some possible confounding variables. This is pretty open-ended. What could be something that would cause blood pressure and heart rate to change in a 20-minute time frame? I'm going to list out some things that previous classes came up with, but if you have other results, I would love to hear about them. Other ideas for confounding variables in this situation. So some of the things that I and other students came up with, how they chewed the tobacco. So whether they actively chewed the tobacco or just let it sit in their mouth. How long they chewed it. It doesn't say how long they chewed it, but maybe some of them chewed it for a little while and others chewed it for much longer. We don't know whether or not the students were smokers. The student participants could have been smokers, which might also have affected their heart rate and their blood pressure. Were all the students of similar age? We don't know. We could have had students with underlying medical conditions. It's possible we had a student with high blood pressure that was there. What else? What other confounding variables could you come up with? Maybe some of them had a test that afternoon and they were worried about the test. And as they were chewing, they started getting a little stressed about the test. And do you think this is a good way to study the effects of smokeless tobacco? Well, this is an opinion. Do you think this is a good way to study the effects of smokeless tobacco? I would say that the experimental design was probably okay with the blocking, the blinding, using the placebo, studying the before and the after effects. But because we used it on university students, we cannot generalize any results beyond university-age student populations.